Do you remember my recent experiments with the RTX Pro 6000? This is a massive workstation GPU from NVIDIA with 96 gigabytes of VRAM. Well, that same line of RTX Pro GPUs has now made its way into laptops. And this one right here is one of the first. This is the Dell Pro Max 14. My first reaction opening this thing, 4 USB ports, and 2 of them are Thunderbolt 5. PC laptops finally have more than one Thunderbolt 5 port. Even the M5 MacBook Pro still does not have Thunderbolt 5. Now, it's not all upside. The downside is that there is no dedicated charging port here. So if you're gonna be charging this at the same time as using it, and you might need to because it's got the Intel Core i9, I'm just kidding, not the Intel Core i9, otherwise it would last like 20 minutes. Core Ultra 9 285H. This is a monster beast. And inside of it is the RTX Pro 2000, a mobile version of the same professional GPU architecture. Now, we know from past experiments, even on this channel, that mobile GPUs are not going to be the same as desktop GPUs, even though they have the same name. But it's nice to see that packed into a thin, portable chassis that's clearly meant for serious developers and people that need extra oomph in their laptops. But also keep that charger handy, just in case. When you do though, you're gonna be using one of those USB-C ports, cutting it down to 3. No dedicated HDMI port. I would have really liked to see that. I'm already attacking it. What's up with me? Say nice things first, Alex. I don't know, these are just the first things that just jump into my mind when I first see this. First impressions. When I open this thing, really nice trackpad. This is the kind of trackpad that I've been waiting for. It's not a diving board, at least it doesn't feel like it. Probably should have read the instructions, but who cares? This is first impressions. It feels like a really nice touchpad, almost Mac-like. We've got the fingerprint reader for logging in quickly. We've got, very important, one finger opening, really nice, solid feeling laptop. And this is the evolution of where Dell XPS was. Dell XPS used to be my favorite Dell laptop, but now I think it's this, except for one thing. They almost have it, but this is kind of annoying. You see this keyboard on the Dell XPS 13? I complained about this keyboard a lot before. All the keys are square and flush together. Here they're also square. They're a little bit further apart, so Dell, you're moving in the right direction, but I still want to see a keyboard that's a little bit easier to find the keys on, where the arrow keys and the control and the space all don't run into each other. I just want a little bit more spacing there so I can kind of feel around instead of having to look down. It's probably having to get used to it thing. But there is a very important distinction in this particular laptop, which is the Pro Max version, in that it has a physical row of function buttons. Yes, hopefully Dell will just leave this kind of function row behind and not come back to it. I really like physical keys instead of virtual keys. 14-inch MacBook Pro, very close to the size and color and the feel. The only difference is I think the Dell feels more like plasticky. This one feels more cool, like a metal, but the Dell doesn't feel cheap by any means. Dell comes in at 1,672 grams, MacBook 1,537. The MacBook is pretty flat. The Dell kind of tapers towards the back and it's a bit taller, probably about 1/4 of an inch. I just love a laptop that you can just hold with one hand, because you never know, you might need your other hand and just like hand it over to somebody. Here you go. Why, thank you. So here's the Pro Max 14 Premium. It's the 14-inch version. We're gonna skip right by the ones they have here, and I'm gonna customize my own. I just wanna see how much this particular variant that I have costs. If you wanna skip this part, go to the test. I'll leave chapter markers down below. First of all, upgrading to the Core Ultra 9 285H, which is the top of the line Intel mobile CPU right now, plus $300. Windows 11, 64 gigs of LPDDR5 at 8400 megatransfers per second. That's the top of the line RAM in mobile right now, and it's quite a bit of it for $830. All right, now I've got selected the Intel Arc Pro GPU, which this machine has in it because it's part of the chip, and I've done tests on it before. You can check out the channel for more videos on that. Very capable chip, but that's not enough for us because we want the NVIDIA RTX Pro 2000. You can also get the 1000. This is the Blackwell generation, by the way. This one has 8 gigabytes of GDDR7 for $420 extra, but no, we want the Pro 2000, also 8 gigabytes of GDDR. I kind of wish it had 16 because that's going to limit us when it comes to running LLMs. If you want full GPU offload, to the RTX card, then you're gonna be forced to run smaller models, anything 8 GB or less. That includes your context. More on that to come. However, a sneak preview, I was able to run the OSS GPT model, 120 billion on this thing. That's right. Let's keep going. I got 2 terabytes of memory in here. What? Storage, I mean. Memory, I wish. And this is indeed a touch screen. 200 bucks extra. But it's not just a touch screen, right? You're paying for the QHD Plus Tandem OLED. Nice bright screen. It says 400 nits, but it's plenty bright. It's got the anti-reflective coating on it as well. However, only 60 Hertz for those of you that care. I've stopped caring as much about that right now, but I know that some of you do care about that. You could get the 100 watt adapter, or you can get the 130 watt adapter, which is what I have here, plus 13 bucks. Blah, 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 blah. Support extra options like Microsoft 365, McAfee, CrowdStrike. Let's skip all that and bring our total to $5,074 for this little beast. Is it a beast though? Let's do our little tests. So these days I'm constantly flipping between models. GPT-4o for notes and email, Claude for code refactors, Flux for image generation, Kling for video, 4 tabs, 4 bills, and counting. Enter Chat LLM Teams. There's one dashboard that houses every top LLM, and Route LLM picks the right one for you for a given task. O4 Mini High for fast answers, Claude Sonnet 3.7 for coding, Gemini 2.5 Pro for big context, and even adds GPT 4.1 before ChatGPT has it. Chat with PDFs and PowerPoints, then generate decks and docs and do deep research all in the same chat. Need human-sounding copy? The Humanize toggle rewrites text to beat AI detectors. Spin up agents and run code with AI Engineer. I built my first bot in just minutes. Track artifacts, create GitHub pull requests, and debug from the same interface. Need visuals? No problem. Use Flux or Ideogram and Recraft for images, Kling, Luma, and Runway for video, all built in. And the kicker is just $10 a month, less than one premium model. Head over to chatllm.abacus.ai or click the link in the description and level up with Chat LLM Teams. First of all, for JavaScript developers, I run Speedometer 3.1, which tests a bunch of JavaScript operations in the browser. And I did get the same exact results in Chrome and in Edge, so we're pretty evenly split there. 38.4 is a really nice score. It's not 51 like we get on the highest end MacBook Pro. That's the M4 variety, not the M5 yet. Stay tuned for that. But this is a very nice score and one of the highest that I've seen on a Windows machine. I also ran the obligatory Geekbench. Pretty decent single core score there. Not the best, but it's pretty fast, and a really nice multi-core score on this one. This chip does have 16 cores on it. I've actually shown this chip in other chassis before, and it does really well. We'll do some multi-core compilations right now. So I'm doing my Mandelbrot test, which basically uses up all the cores at the same time, and it does a Python Mandelbrot algorithm. This shows how if you max out all the cores at the same time, we're gonna hear some fans. Oh yeah, can you hear that?
A few moments later.
Not for too long though, because this thing finished in 24 seconds, and that is really nice. So I'm running this a couple more times. First of all, to get the same number. Yeah, it's the same exact result, 24 seconds, but also just to get a little bit of the thermal reading here. We're going up to about 41 degrees here at the hottest points. This is kind of a nice little thermal layout here. Notice there's no heat at all where you're gonna keep your hands or the trackpad. A little bit warmer along the middle keys, but no hot spots, which is nice to see. And we're at 25 seconds for the third run. As you can see, that's a pretty intense test, although we are not using these 2 last cores. Not quite sure why that is, but the utilization is only about 80% max here. So potentially we could go faster. It's just that it looks like this test is limited to the 14 cores instead of all of them. And before we get to our LLMs, to really try that RTX Pro 2000 out, let's do a compilation test. This is a .NET compilation, and it's a representative of a pretty large program. I generate over 100,000 namespaces and classes and then do a compilation on them. Git repository has too many active changes. Of course, it's got 100,000 new classes. Thanks, VS Code. All right, building the project. This one takes a little longer, as you'd imagine. Listen to that. I'm pushing it pretty hard right now. Whoa. This fan's intaking on the bottom. 102 seconds total. Not the best that I've seen, especially for this price, for this kind of machine. It's a pretty intense machine, but the numbers don't really add up. It's not the fastest thing. All right, let's switch over to some LLM tests. Many of you are familiar with Llama CPP, a very popular backend that can use CUDA, it can use Vulkan, and that's what LM Studio and Ollama, tools you might have heard of, that's what they use as a backend. So I'm gonna run it directly. I actually compiled this on my machine for CUDA. It's also available to install through Winget. I'm gonna run the Vulkan version, which is the one that's available through Winget. Vulkan is a nice library to do this kind of stuff. It works cross-platform and it's pretty fast. So right here we can see that for Qwen 7B, PP512, that's prompt prefill. That's the first stage that LLMs go through. And that's going at 1,154 tokens per second, plus or minus 73. And token generation is at about 50 tokens per second. And you can see that we're using Vulkan as the backend here. Pretty small model, pretty small context, but it gives you an idea. I got some larger context tests coming up here. Here's Llama Bench with CUDA as the backend, the one I compiled locally, and you can see the difference right there. Wow. This is why CUDA is still number one and still leading the way in speed, in compatibility. I mean, that's what it is right now. It's CUDA. I want there to be more competition. I like competition. It's good for us. So let's take a look at that. There is the GPU, and we had that little bump right there when that inference was running, or that Llama Bench was running. We've got 1,797 for PP512 prefill, and generation, or decode as sometimes it's known, that second stage, we got 55 tokens per second there. Both of these ran on the Blackwell GPU, by the way, not on the iGPU, but you can see a huge difference depending on what kind of library we're using. And LM Studio is a tool that I kind of enjoy using. It's got a nice front end, very easy to use, very easy to set up your own server. They did not pay me for this. I just like using it. And you're able to select the runtime that you want to use. So right now I have CUDA selected here. You can select Vulkan or even run it on the CPU if you really want to torture yourself. That's going to be really slow, by the way. Now, if you're running Llama CPP directly versus running LM Studio, there might be a little bit of a difference there. So let's take a look at what the difference is. I'm going to load that same exact model up here in LM Studio, and I'm going to give it my medium architecture prompt that I've been using. Let's go. So there it is. It's thinking. It's going pretty fast. That's decently fast. And we can see that it's happening on the GPU. This is the smallest context, by the way, 4096. And there we go. It's generating. This usually gives me a pretty long response. And if we stop this, 39 tokens per second thereabout. So quite a bit less than what we saw before, which was 55 directly through Llama Bench. So you can see there's a little bit of overhead. So you can set up a local server and serve it directly with Llama CPP, or you can use a tool like Ollama or LM Studio to do the serving for you if you want to use it as, for example, coding assistant, right? You can hook up your VS Code, and I've shown other videos on this channel how to do that. You can hook up VS Code or Zed, whatever editor you're using, to be able to talk to the locally running LLM or an LLM running on a separate machine, for example. Now I'm gonna unload this model and reload it, but this time I'm gonna adjust the context window. And I wanna keep it just under 8 gigabytes because that's all that this RTX Pro 2000 can fit in it. So I'm gonna keep it here at around 20,000 context length, just to see if we get any kind of difference in the response here. Here's that prompt again, boom. Looks like we are all on the GPU here. 6.6 out of 8 is being used, and there it is, GPU at work. So let's stop that. We're still at 38 tokens per second, so that's pretty good. If we load this up again, but give it 50,000 tokens, then we're over our budget for that GPU. And let's see how that affects things. So right now, what's happening? Oh. We got a little bit of a freezing going on here, but we're good, we're good. What? Okay, it's freezing on me. It's freezing on me. It's not liking that one bit. It's trying to figure out, what am I gonna do with all that LLM data? Where am I gonna put it? Oh, so it's filled up the GPU memory right here. Oh, the fan is going. Can you hear that? Listen, that fan is really kicking up a notch now. And this also has to go to system memory now, so part of the model can process on the CPU as well. But I'm not liking the fact that my mouse keeps getting frozen. That's not cool, because we still have a lot of headroom in our system memory, so we should be able to run even larger models here. But we do have some struggling going on. Haven't even printed our first token yet, so it's definitely not liking that, at least not LM Studio. I was able to run OpenAI's GPT OSS 120B though. Look at that, LM Studio filled up 5 gigabytes out of that GPU, and now it's going up into system memory, and that system memory just going up. It's going. 63.5 out of 64 gigabytes being used right now. Model is still not quite fully loaded yet, but we're getting there. And it loaded, which is quite surprising to me. It's a pretty big model, but this is a sparse model. Even though it has 120 billion parameters, it's not actively using all those at the same time when you run a prompt. So let's run our prompt and see what happens here. It's actually thinking, look at that. So this model with more parameters and more memory requirement is actually working a little bit better than the small model with a huge context. So that gives you some idea of what could happen. It's not only the size of the model, it's not only the parameter number, it's not only the size on disk, it's also the context that really matters here. What I'm not seeing is the GPU utilization. I am seeing that we are using 6 out of 8 gigabytes of the RTX Pro 2000, but 0 utilization during this generation. Seems like most of this is happening on the CPU and using system memory. There is some activity going on iGPU, but very little. It's like 8%, and there it goes. It's not fast, but it's a 120 billion parameter model. Let's take a look at the speed here. 10 tokens per second. I ran a few of these models using an automated script that I created to get some averages on different machines. And there is our ProMax RTX Pro 2000. Now this is the only machine on this list that's a laptop. The rest here are desktops. Sorry that it's yellow, but that's what I decided to paint it as. And you can see that this is keeping up quite nicely with some of the desktops, like the Framework desktop with the Strix Halo chip, probably the best mobile APU right now out there, up to 128 gigs of memory there. GMK Tech Evo X2 also has that same chip in it. And the Evo T1 has the same chip as this machine right here, the Intel Core Ultra 9 285H, but look at the difference there. That is a huge difference. Even though the CPU is exactly the same with the same iGPU, that discrete GPU in this laptop really kicks it up a notch. So for example, that medium architecture prompt, 37 tokens per second for this model, whereas on the iGPU, it ran at 9.7 tokens per second. Here's Qwen 3.4 billion, another small model. By the way, don't discount small models. They're capable. They have their own uses too. I'm gonna take off these crazy ones. This is the Evo T1 with an external dock running at 5060. That's why we have such crazy speeds there. Here's ProMax RTX Pro 2000. The pink one is the one that's sticking up above everything else. Above M1, which is green, M1 MacBook Air, M2 MacBook Air, which is purple, M3 MacBook Air, and M4 MacBook Air. It just more than doubles the M4 MacBook Air performance, and those are laptops. Now, M4 Max MacBook Pro is a different story. That one is more than double of this machine. Even though that's an Apple Silicon chip, it's not running CUDA, it's running MLX. You can see the performance difference there. That is a powerful chip. And now we're gonna be getting the M5s soon, so those are gonna be even crazier. Stay tuned to see those videos. Medium architecture prompt. M4 Max, we got 145 tokens per second there, 61.7 tokens per second on this machine. One more. And sorry that these are always a different color. I don't know how to keep it consistent using this thing. I'll have to figure that out another time. But there's our M4 Max MacBook Pro, this time in pink. And the Beelink GTI 15 with the same chip as here, but that one ran with an external RTX 5060 Ti. By the way, those videos are also available. I'll link to them down below if you want to see those. However, let's talk about that for a moment. This is an NVIDIA card that's in here. And the mini PCs that I ran with an external dock also had an NVIDIA NVIDIA card inside the external docks. And we can see those, the red and the green here, that are way faster. For example, here is GMK Tech Evo T1, this machine right here with an external RTX 5060 running this Gemma 3 4 billion at 111 tokens per second. And this is the higher context test that I was talking about. These go up to 50,000 tokens. This machine for that prompt got 71 tokens per second. All our MacBooks are down here. M1, 21 tokens per second. M2, 22. M3, 23. And M4, 32. Big jump for the M4 there. Of course, the M4 Max is going crazy at 140 tokens per second. But the M4 Max has a memory bandwidth of over 500 gigabytes per second, whereas the RTX Pro 2000 is about 288. So overall, a very capable machine. Feels nice if you're in a Windows environment. I haven't tried Linux on this thing yet. Very solidly built machine, capable. $5,000 though, probably not what I would get myself because it's a little bit on the pricey side for the kind of performance that you're getting. I would expect to see some really nice performance out of this thing. That RTX Pro 2000 card that's in there is going to get you into the NVIDIA and the CUDA ecosystem, which is kind of where you want to be if you want to do production deployments in AI these days. So on that front, it's a good investment. There aren't that many cards that have the RTX Pro series of cards in there. But also at that price level, now we're talking about deciding between a MacBook M4 Max or an M5 Max that's going to be coming out soon and this machine. So it really depends on whether you can do your work on a Mac or on a PC here. This thing is definitely a powerhouse. I haven't compared it yet to some of the other PC laptops that I have as far as performance goes, but let me know in the comments if you want to see that, and I'll see you in the next video.